Activity 11.10 is Polygon areas by dissection. So this activity you see many curricula out there. You will need a material sheet from the appendix. Looks like this. If you have colored paper, I printed mine on colored paper. You can also color it in later, unless you'll be taking white on white. And the very first thing we need to do is cut out the rectangle that is numbered 1, including along the diagonal line. So we can go ahead and cut these out. We'll take them down, don't do that yet. You want to take and put them below so they have the same orientation, because then we can see if we put them on top of each other that they are congruent. So you can pass that, go ahead and put them down. And then the question, so what shapes form? You have two congruent right triangles based on what you know about the area of the rectangle, describe the area of the rectangle. So this is description, and the area of one triangle equals half the area of the rectangle. That would be description. Write a formula for the area of a triangle. And the area of a rectangle is based on height. So the area of the triangle would be half of that. So 1/2 is height. Something to note in the original rectangle, so the length, we said what's called the base, and the height is what we typically call the width. So this is the base and the height. And I want you to pay attention that they form a 90-degree angle, or right angle. That's part of that rectangle. You'd be under the two right triangles when you cut that. So don't forget to fill out part 3. We'll go to number 2, and we're going to cut out shape 2. So it's another rectangle, but then there are 3 triangles inside this one. So the second activity is going to be about showing that the formula that we found for the area of the triangle works inside any triangle, even non-triangle. So hopefully that these 3 triangles. The area of the larger triangle. So let's go ahead. I'm going to take this one down. We want to know how that compares to the area of the original rectangle. Well, the other 2 pieces that you cut out, you want to show that the 2 smaller pieces are the same area as the one large triangle. So you'll have to do, it's like a little puzzle. You'll have to do a little bit of work, but you can put them both on top of that large triangle, and you show now that the large triangle is still half of the area of the rectangle. So when we take these down, we still want to take them down so we show that they are equivalent triangles and with them. Okay, so the formula for the area of the largest triangle is still 1/2 times the base times the height. So here's the base. Now I don't have the height that was the original height of the rectangle, but I do in the second one. So this entire bottom side, which is that was the base, but now I can see the height and I can still see that 90-degree angle. So a height in the inside the triangle has to make a 90-degree angle with the base. So obviously compared to the formula in number 1C, they are the same. So for any triangle, the area formula is 1/2 base times height. Yes. Moving along to shape number 3, that's another rectangle. So I'm down here now, I'm going to cut out that rectangle. And again, we're going to cut on the dotted line. And I will be left. A triangle on the opposite. So these are the two shapes of cut off the rectangle. So what shape did you start with? You started with a rectangle based on what you know about the area of the rectangle. Describe the area of the parallelogram. Well, what I need to do is show this as a parallelogram that is not a rectangle. And what we can do is move this little piece over to the side. And now it looks, you take it down, it looks like what we think of as a parallelogram. So I didn't cut anything in half. I didn't take anything away. I didn't add anything. So they have the same area. Well, that would mean that the area is base times height. So I didn't cut the base. The base is right here. This is B. And I can still see the height of the rectangle. So it still makes a 90-degree angle. Now, you don't have to have the height be in that corner. You can measure your height anywhere inside of your parallelogram as long as you make that 90-degree angle. So I can still see the cutout from the rectangle and make that my height, but I can also have it inside of my parallelogram as long as it's perpendicular to the base. Four is a parallelogram. I'm going to start with a parallelogram this time. And when we put it on the dotted line, we get two opposites. Okay, so first I'm gonna put them on top of each other. So it wasn't random where the dotted line was. It was exactly so in the parallelogram, so you end up with two congruent opposites. For this one, I am not gonna put them back to the parallelogram almost. I'm gonna separate them a little bit. And that's because this is the first shape where we actually cut the base apart. Okay, so we got the two trapezoids, isosceles trapezoids. Based on what you know about the area of the parallelogram, describe the area of one of the shapes. It is half the area of the parallelogram. I want the area of just one trapezoid. So the formula then, well, let's think about this. The area would be 1/2 times the base times the height. So this is the base of the parallelogram. We said the height can be anywhere inside the parallelogram. So I can go inside, make a 90-degree angle, and call that H. The issue is that that B is now split, but if you remember, these two trapezoids were congruent. That means that what you have down here, this little piece, is now up here. So what we say is that we split our base into a base 1 and a base 2, where the base 2 now comes to the parallel side in that trapezoid. So B is actually equal to base 1 plus base 2 times the height. The base and the height still form a 90-degree angle, and we will have to know that base 1 is parallel to base 2. So in a trapezoid, you don't get to pick which side is the base, which you actually put in the triangle and the parallelogram, but in this one you cannot. And you have the two parallel sides are base 1 and base 2, and then the height will be perpendicular to those. Here's number 5. So go back to the cutout. And this is a rhombus. So we're going to cut out our rhombus. And again, on the dotted lines as well. Let's pull a tiny bit off. And actually, just have some off. But we do have the outline there, so we can remember our sheets. It tells us that we need to rearrange these three triangles and make them into a rectangle. So let's see if we can do that. We cut it in half, and then one of those has done. I don't know if we can angles. Middle. That's it. So I can rearrange it, make it look like that. Take that. Okay, we have our breath. We started with a rhombus. We got 3 triangles that we made into a rectangle. So we again didn't cut it in half. We didn't subtract anything. We didn't add anything. So the areas are the same. So description of the areas are the same. Rectangle was base. Nice. Of course, if you look at those dotted lines in here, this is inside of your rhombus. We call that a diagonal. So I'm going to call that D. The height over here, not going to see that, but I will highlight it here. So this D is now equal to B, and this D is now equal to H. So having two D's is confusing, therefore we call this D1, and this D2, but we only have half. D2 would go all the way across, right? Like it would keep going all the way over here, and we only use half of it. So what does that mean down here? My base is now D1. And then I have 1/2 of we usually write that as 1/2 and D1 and 2. Notice that these make an 90-degree angle. So our height, or based on our height, still make that 90 angle over here as well. So the formula is 1/2 times V1. And one more for us, and that is the height. Back to our material sheet, and we're going to cut out height. Okay, we want to rearrange these pieces to get a parallel. Give me a minute. I want to make sure that the dotted line is part of my base. This. With this one, yeah, so we cut the height of that. I'm going to take it down. So again, we set that dotted line. And it's really down. I did have to flip one of the pieces over. So we started with a height with two triangles. Again, we didn't half it, we didn't take anything away, we didn't add anything, so the areas are the same. Area. Space. And then on the inside here, perpendicular outline base. So where is that? Well, this is the base. Which is diagonal. So what we just did with the rhombus. If you look in here, this is what the height was. It's that 90-degree angle. And then again, is equal to 1/2 the diagonal. So for clarity, we're going to call it D1 and D2. And look, the base is diagonal 1. The height is 1/2 of diagonal 2, and you get 1/2 of diagonal 1 of diagonal 2. And that would be the area formula for the height. If you have a polygon that is not one of these shapes, let's say you have a regular hexagon. Regular hexagon, you can cut into 2 trapezoids or 6 triangles. If you have an odd shape, cut the inside into shapes that you have formulas for. And we're going to look at some other techniques, but these are the common formulas. And then odd shapes, we try to use these formulas under its